Hello everyone! I'm happy to announce the official launching of 3D printing to your library. In this two-part presentation, you will learn the basics of 3D printing and design. In the second tutorial video, you will learn a hands-on component on how to successfully 3D print your object. I hope you enjoy this mini presentation and utilize the 3D printing. I'm sure you all know, but Margaret Val is the academic librarian that is overseeing this 3D printing project. So if you have any questions or clarifications, please feel free to ask Margaret for any advice or suggestions. My name is Michelle Vasconcelos, and I will be instructing this presentation. I am a digital design technician at the Toronto Public Library and also a graduate student at the University of Toronto. Margaret and I have been working together to improve this workshop for you all to enjoy. Our main objectives are for you to have an understanding how 3D printing is relevant and applicable in an educational context. The second presentation will focus on the hands-on portion on what software and what steps to go through when you successfully print your 3D printed object. Your library is investing in 3D printing because libraries in the digital era are not just about books anymore. Libraries reflect how people learn about subjects using new technologies. Having 3D printers in libraries improves collaboration and knowledge exchange between people interested in learning about it while removing barriers to entry. Having 3D printers in a university library makes the technology available to all students rather than restricting its use to engineering or science departments. 3D printing promotes student achievements and also prepares them for a college education. Students develop the confidence that allows them to pursue challenging courses such as those in STEM fields. 3D printing makes it possible for every student to dream bigger and better. There are so many examples where 3D printing can be beneficial to education. For instance, biology students can print organs, chemistry students can study 3D printed molecules, graphic design students can create 3D versions of their art, history students can print historical artifacts, architecture students can also print 3D models of their designs and blueprints. Another example could be that many patients in long-term care have dentures, missing teeth, reduced tongue strength, and other changes to the oral cavity which can make biting or chewing very difficult. Therefore, they need to have the texture of the food modified, but modified textured food looks unappetizing, so patients don't really eat. So therefore, creating a 3D printed food mold could make food more palatable, as it should hopefully increase their nutritional intake. So as you can see, 3D printing is applicable in all fields and in everywhere. So it's important to acknowledge that 3D printing is very intersectional. Some more examples include MIT has its own graduate and advanced undergraduate course teaching the fundamentals of 3D printing. The University of Texas and Virginia Tech have also followed suit with their own courses and certificates covering 3D printing and design principles for additive manufacturing. 3D printing also provides many opportunities to aid visual and practical learning across the sciences. 3D printing components are often used as test modules for scientific experiments across the disciplines, including mechanical engineering, aerospace, and robotics. 3D printing uses a printer to create three-dimensional objects. For example, a cup or a Yoda doll or a phone case. 3D printing has these qualities. Objects are created by adding or depositing layers of material, not subtracting or cutting out pieces from a block of material. 3D printing is done by building up the object layer by layer. Usually 3D printers use plastic because it is easier to use and much cheaper. At your library, the printer that you have available is called the Ultimaker 2 Plus Connect. And the material that you'll be using to print your 3D printed objects is a material called PLA, which is short for polylactic acid. Before we move on to the hands-on portion of this presentation, I wanted to state a brief summary of the process of 3D printing successfully. The first step is to download or create a 3D model. For instance, if you'd like to browse files to download, feel free to go to www.thingiverse.com to download a 3D design. If you want to design something personally, create an account on Tinkercad. It is the best for beginners. After you've retrieved your file download, which is an STL file, you must slice it using a software called Cura. Cura essentially converts your 3D model file into a G-code. So your STL file into a G-code. A G-code is a set of coordinates or language for your Ultimaker 3D printer to understand how to successfully print your object. So basically you design, you slice, and then you send the object ready for print. I will go into that in detail in the second part of this tutorial, as we will successfully create a keychain.